Okay, good afternoon. Thank you for joining IPv6 deployment section. The purpose of this section is try to introduce all the IPv6 deployment experience, and some from business consideration, some from technical consideration, and try to smooth the IPv6 transition from different perspectives. So I'd like to, we have five speakers to this afternoon section. I'd like to introduce the first speaker, Tomohiro Fujisaki from NTT Communication. He's going to introduce the IPv6 deployment in Japan. Okay, you can go upstairs.
Okay. Can you hear me? It's okay? Oh, great. Oh, thank you, Kenny. My name is Tomohiro Fujisaki, working for at the NTT Communications Corporation. And today I'll speak IPv6 deployment status in Japan. And this presentation is a joint presentation with me and the Dr. Yoshiki Ishida. He may be on the line and the line, and he's the head of the IPOE Council. Okay, let me start from my self-introduction. Again, my name is Tomohiro Fujisaki and working for the NTT Communications Corporation and currently in the IP Information Security Department. And my main responsibilities in my company is the IT system governance within the whole NTT Communications and also network resource management such as IP address, domain name, and AS numbers in my company, and the operation of the internal security systems such as the EDR or UEBA. And I have been working outside the company in the community such as the APNIC and IA Japan. In IA Japan, I am a chair of the IPv6 deployment committee, and JIPA, this is the Japan ISP Association, and I'm vice chair of the home router working group. And also, I'm the chair of the ISAC Japan IT Security Working Group and the chair of the ISAC Japan chapter. Okay, let's move to the main part. So, in the next few slides, I'll introduce the Japan IPv6 penetration statistics. And as many of you know, the Google has been providing IPv6 penetration rate for each economies. And as you can see, the left graph, the Japanese IPv6 deployment is gradually increasing. And recent Japanese IPv6 adoption rate is about 49%. And next statistics is provided by the Akamai, and Akamai says the Japanese IPv6 adoption rate is 46%. And they also provide the ranking of the economies, and the ranking of Japan is the 17th. And Akamai also provides the ISP level statistics. And this red circle is the Japanese main ISPs, KDDI and SoftBank and the NTT Communications. And the ranking of the ISPs is 16th and 22nd and 32nd. And the third statistics is from the APNIC. And the APNIC says the Japanese IPv6 penetration rate is about 56%. And the ranking of the Japan is 18th. And these are the outside Japan-based observation. And next slide shows the inside statistics. The left table shows the fixed line status, and in the March 2021, over 80% of the access line uses IPv6, and also the mobile area. At end of the start of the last year, over 70% is IPv6 ready. So as you can see, the outside statistics says about 50% for the IPv6 penetration rate in Japan, but from the internal point, over 70 or 80% already IPv6 ready. So we are examining what is the difference between these two statistics. Okay, next I'll introduce some statistics by IPOE Council Japan. And IPOE Council Japan is an organization consists of the IPv6 access line providers. And they started to disclose their access line information from the 2023. And the purpose of their disclosure is to promote IPv6 compatible content development and provide objective data for policy and the strategy decisions. And of course, the third point is support fair internet market expansion. And this table shows the number of IPv6 subscribers in Japan. And September last year, in Japan, we have over 16 million subscribers and 261 ISPs using the IPv6 services. And next figure shows the IPv6 conversation rate. And the blue area shows the access line, IPv6 and IPv4 connectivity users. And the light blue line shows the IPv6 rate. As you can see, both the whole subscribers and the IPv6 subscribers has been increasing. And from the viewpoint of the traffic, this two figures shows the IPv6 and IPv4 dual stack traffic rate. As you can see, the October last year, the IPv6 traffic rate is over 60%. So many users in Japan has been using the IPv6. Okay, from the next few slides, I'll introduce the IPv6 service in Japan. And in Japan, many providers started to provide IPv6 only infrastructure to their end users. And on that network, of course, end users want to use the IPv4. So from the IPv4 viewpoint, the IPv4 connectivity was provided by the IPv4 as a service function, such as IPOE or NAT64. And the network itself is IPv6 only. And for some devices, some home router vendors started to consider to provide the IPv6 only functions, such as IPv6 most-story functions for their networks. And for the end user communications, they started to implement IPv4 P2P functions, such as UPnP IPv6. Okay, next slide shows the IPv6 connectivity service by the NTT Group. And in Japan, NTT is a local carrier and provides access line service in the whole Japan. And this is not the ISP service, but only the access service from end users to the ISPs. And recently, they started the 10 gigabit access line service for the end users. And their base network is IPv6 only. And NTT East and West provides a tunnel-based, PPPoE-based IPv6, IPv4 dual stack service in the same time. And in this infrastructure, many ISPs provide the internet service to end users. And for PPPoE IPv6, IPv4 dual stack service, and IPv6 only service using the NTT's infrastructure. And in this case, the IPv4 is provided by the IPv4 as a service function. And also some enterprise company uses dedicated line like services. And these are the fixed line situation, and this figure shows the mobile access line situation. So recently, NTT Docomo started to provide IPv6 single stack service below here. And in this case, the end users mobile devices has only IPv6 address, and to access the IPv4 internet, they use the IPv6 IPv4 translation function. And this is the implementation of the IPv4 access mechanism by NTT Docomo. They implemented in the network NAT64, DNS64 function, or the NAT464 function to provide IPv4 access to the for the end users. Okay, so this is the last final part that I'll introduce recent IPv6 discussions in Japan. And first one is the IPv6 home router specification discussions. We have the IPv6 home router working group in the JIPA, and they have been discussing the IPv6 home router guidelines. And these guidelines define the minimum requirements for home routers in the Japanese internet environment. And as I said, so in Japan, we have the access line, IPv6 only access line, and the IPv4 has been provided by the transition functions such as 464 extract, dsLite, and mapb. So to use the IPv4 internet, the end user devices, end user home routers have to select which kind of these transition protocols was used by the each ISPs. So in this working group, we define the automatic selection mechanism for that protocols. So if you are interested in such kind of the guidelines, we have the English version on English version. So please refer this URL for the guidelines. And next is the IPv6 UPnP discussion. And so we believe that for further promotion of IPv6 end-to-end communication, the firewall traversal technologies will be necessary. And some Japanese vendors implement IPv6 UPnP function, and some content provider provides services using such IPv6 traversal techniques. So if you have interested these devices or these such kind of services, please refer the below announcement. Okay, this is the discussion in the IPOE Council. And as many of you know, in the worldwide, many content hyperscalers is IPv6 ready. But in Japan, the content provider is not so implemented IPv6 widely. So in IPOE Council, why the Japanese content provider do not implement IPv6? And one of the reasons is the lack of the geographic information for the IPv6 address. So they started to standardize how to provide the geographic information for IPv6. And so actually, IPOE Council members is access line service providers. So they have been providing the access line information, allocation information for the prefecture base. So just now they have been considering the announcement format or how to provide such kind of information efficiently. Okay, this is final slide. And as I said, the IPv6 is commonly used in Japan, and it is possible to obtain IPv6 connectivity everywhere in Japan. And implementation of the functions to provide IPv6 only network has been developing in Japan, and also efforts to promote IPv6 usage, especially in the content side, will be discussed and try to promote such kind of content. Okay, this is end of my presentation, and attached there about the IPv or IPOE council information. And if you have interest, please refer the slides. Okay, thank you so much.
Thank you. And any question, please stand before the mic and say your name and your affiliation. Okay, hearing none. Thank you. Before you leave, Thank you very much.
Thank you.
Thank you very much. I'd like to welcome the next speaker, Professor Suresh Warren and Romadas. He's going to introduce IPv6 and 5G. He's the chair of APEC IPv6 Council. Let's welcome Professor Suresh Warren.
Thank you, Kenny. Good afternoon, all of you. I see a lot of IPv6 experts sitting around the room today. So the presentation I do will not excite you too much because you guys already know about what I'm going to talk about. But still, there are some people in the room who are asking about how exactly will IPv6 fit into 5G? And that's what I'm going to talk about. So this is too long for 15 minutes, but I will scan through some of it and focus on some of the important issues. Introduction to 5G networks is handled by the 5G people. So as you all know, we are now implementing 5G in most of the countries. And the organizations that are mainly pushing 5G, 3GPP, ITU, the evolution that has taken place. And if you notice, one of the main things about the key drivers or the evolution and the move to 5G is, like anything else, bandwidth. But with bandwidth comes another very important feature of 5G, which is up to 100 times number of connected devices. So what 5G wants to achieve is basically a fully connected world. Even your mobile phones, if they have 5G, you're looking at basically 6 antennas minimum without MIMO, right? So you have each set. You have an antenna for the sub-6, you have an antenna for your 3.5, and you have an antenna for your millimeter. And each of these comes with 2 sets of antennas. And if you look at MIMO, each of it comes with 4 sets of antennas. So that's 4 times 3, that's 12 antennas in your mobile phone today. So imagine 12 antennas means 12 different IP addresses if you really want to move things quickly. So 5G key drivers, 5G is basically once it's there and once it's deployed and once it's becoming common use, it will take over anything and everything that is basically going to get connected to the internet. 5G is on the way. It's not fully there yet today. Most of you currently have access to 5G over your mobile phones, and pretty much that's the limit as of today, but there's a lot more work that's going on in the background for 5G. These are the new services with 5G, IoT connectivity, timelines, and the overall architecture. Interestingly, 5G's architecture, for those of you who are not familiar with, the data plane and the management plane are kept separate, physically separate. So this is done mainly to protect and for issues of cybersecurity. So earlier within the 4G architecture, the users can access management plane. But with 5G, the management plane is a separate plane. It runs a separate protocol. Doesn't even need to be an IP protocol that really attaches or communicates within that part of the plane. Network slicing is an important thing, and this is another feature where 5G plays a critical role. So as you all know, 5G, big, fat pipe, and I can slice it. The beauty is I can sit in front of a terminal, and in 2 minutes, using a dashboard, I can slice up my 5G bandwidth into different allocations of bandwidth. I can allocate 3G to the 3 meg to the accounting department. I can allocate 1 gig to the to management's network. I can allocate 10 gig to R&D's network. I can do that. And I can remove it. That's the beauty of it, right? The management console. Network function virtualization with 5G allows you to basically virtualize functions, so security can become a virtualized item. You can take the entire firewall, virtualize it into the network. And again, you need addresses to do all of this. IPv6 is the answer. And this is basically the different frequency elements technology today. And now we have mobile V6 and 5G. So if you take a look at most IPv6 rollout today, this is slightly outdated, 20019. It was 24%. And the reason I put this slide here is to show you the difference that at that time, 20%, today, more than 60% of the internet is IPv6. We've achieved more than 50% IPv6 traffic over the internet now. Right? And the scale up is so fast. In 2019 to 2025, that's 4 to 5 years, you've gone up double. So imagine in the next 5 years, probably it will see the exit of IPv4. Malaysia as a country has announced 2028 is 2028 IPv6 only. So this has been announced by the regulators in Malaysia. So technically, the entire country will become IPv6. But then there is discussions not to remove IPv4 to allow IPv4 as well. But it is definitely mandated for IPv6. Every home, every device will have an IPv6 address. IPv6 for 5G. 5G is all IP-based traffic. There's no more voice channel. Unlike your LTE, 4G, you had a voice channel. 5G is all data. So pure IP, which means pure IP addresses. And with IPv4 already gone out, not enough, IPv6 is the only solution. This one is interesting. As you all know already, how you slice up this is mainly for those of them who are kind of new in terms of IPv6, but the smallest address place you can give is a /64. Now, I am doing a study on optimization of IPv6 addressing because I feel that /64 to an individual is just way too much. But /64 to an organization can actually survive on one /64 IPv6 address because the rest of the organization can stay routed within the other /64, the local addresses. So instead of giving them a /8 or a /24 addresses of IPv6, you just really need to give them a /64. And you think deeply about it, it's actually much more better in terms of routing, and it's also much more secure. Because the rest of those addresses all remain. It's sort of internal IPv6, but they're externally routable, but they belong to your organization. And if you really look at the larger scale, in fact, an entire country can be routed on a single /64 on a larger scale. And that takes a little bit more work. So you could have a whole bunch of V6 addresses for a country. That's the amount of addresses we have with IPv6. IPv6 address allocations, I think all of you are familiar with it, so I won't go through this part of it. And this one is another interesting thing that I've been working on with some of my students. We call it My IP, My ID. You could give permanent IPv6 addresses to people and their families and their animals and their devices for the rest of their lives and the lives of the next generation and the next generation and the next generation because we have that many IP addresses, IPv6 addresses. So you could give 1 million IPv6 addresses to each family on this planet, and you still not run out of it. You still have so much. That can come from 1/64. And that becomes your permanent IP, which means you don't have to keep changing IPs. And it could sit in a safe mapping location where anytime people want to talk to you, they use your IP to talk to you. So in that sense, you know that security is defined. So if the bank wants to correspond with you, they correspond with that particular IPv6 address. That address then gets forwarded to wherever you are. Right? So you could spoof an address when I'm sending it out, but on a return path, the internet guys look after that. They make sure that the return path is always safe and back to your original address. So by keeping such a design, we could ensure the security of people. Right? So, and you could keep these addresses. No matter who the ISP ends up being, you could keep these addresses because the addresses get forwarded. So it's a very nice thing to think about and work that can be done by a good PhD student. These are other architectures. So implementing IPv6 over the 5G evolved packet core can be done pretty straightforwardly. It's not a difficult implementation. This is the architecture of the evolved packet core. These are some of the designs that will put 5G and Net 5.5G, which is the wired part of 5G, together to be able to push high bandwidth from one end to another end, from consumer side all the way to data center, data-centric side. There are other designs as well. There are other wired technologies that can be used. This particular design is something that I've been studying on. Net 5.5G and basically IPv6 can provide high-end user connectivity. Again, this one is a little more skewed towards security and cybersecurity. The APAC IPv6 Council white papers on full 5G enterprise connectivity have been published. You can download this from the APAC IPv6 Council website. We also have papers on 5G, and we have also papers on 5G enterprise. And the latest one we are doing is on 5G test beds and actual implementation, case studies that we're doing right now. Again, another item that brings IPv6 and high connectivity like 5G to the surface is AI. Today, everyone's talking about it. Everyone's into AI. If you have not used ChatGPT, you can try it out. Now you got DeepSeek. You got many more coming up. I used an AI program to do a drawing. It's fantastic. I mean, in 3 minutes, I became an artist. I drew a really nice picture, right? So its capabilities are incredible, but understand with every little request you make to an AI server, there's a lot more connections and computing power that happens in the background. A lot of processing happens. It needs bandwidth, it needs throughput, it needs connectivity. So all of these bring, number one, high-speed connectivity, which 5G and 5G wired, like Net 5.5G, can provide. And on the other side, IPv6 connectivity, where everything then becomes connected in the world. With this, I'm not going to talk about the IPv6 worldwide-based 5G implementations. Basically, every 5G network being implemented out there is IPv6. I've not seen anyone that said, I'm going to do an IPv4 5G implementation. So it's no point for me to discuss something that's a moot point as it is anyway. And if there's any other questions, you all can feel free to ask me.
Okay, any question, you can go to before the mic. And say your name and your affiliation, if any.
My name is Andre from Universitas Islam Indonesia. The concept of the my ID is quite interesting. So, I mean, like if you own the IP, in terms of operator, you will have the transit and everything else. So how are you going to do this one for individuals to have such IP if you're moving from one operator provider to another provider? Thank you.
Right. So something we talked someone trusted has to maintain that for you, like your regulator or a trusted ISP, where the ISP offers it as a separate service. Not because you're with them, but it's a service, right? You pay $1 a year and you get this service. But it's more of, they are saying, if you take this service, you can be part of my customer base, but you're not restricted by that. You can take the service and not necessarily be part of my customer base, but it's a service. So whenever you move to a different ISP, as I said, the addresses map, right? The address belongs to you anyway, but the address will have a mapping address. So for example, if you are now connected to another network or you will be on another thing, you automatically map that address to your mobile phone, for example. Let's say you're roaming, you go somewhere else, you automatically map it. It's an old technology, it's not new. It's what is that, home, I forget, forward to your home address. There's a word for it, I've forgotten the word. But it's an old, even with IPv4, it was the same technology that was done. Basically, when you're roaming, you can use that technology. It's not a citizen ID. So this is something that is your ID. It's not a citizen's ID. So it's not a country's ID. It doesn't take away a country's ID. So Indonesia may have your own ID. Your passport is still your passport. This is your internet ID. So you want to have an internet ID, you can do that. And usually it's the government or the regulator that will manage it. Because people trust the government or the regulator of a country. So they want them to manage it. It's a nice idea to play on. The main target of that whole project is security. Today, there's so many scams out there. You don't know who, especially with banking apps, you don't know who is connecting and who is replying, who's responding, and who's stealing your money. Right? So the way that anything and everything works on the internet is IP addresses. So if they're communicating to the correct IP address, it's going to be very difficult for someone to try to scam or steal money.
Okay. Thank you. Because of time limit, thank you, Professor Soris
You're most
Warren.
welcome.
Before you step down, send you the gift. So I'd like to invite the next speaker. The next speaker will be Ms. Azura Mat Salim, and from Telecom Malaysia. She is going to introduce transitioning into IPv6. Are you ready? So you can go on.
Okay, so good afternoon, everyone. Okay, so this is normally my problem when presenting at an event, the microphone. Okay, so Assalamualaikum and good afternoon, everyone. So my name is Azura Mat Salim from Telecom Malaysia. So I realized that I didn't provide any background info to the program committee. But first and foremost, before I start, I'd like to thank the program committee for thinking of IPv6 when they put together. So it's nice to know that IPv6 has not been forgotten. And based on today's topic, there are some recent developments ongoing. So it's good news for some of us who has been trying to propagate IPv6 for many years. Okay. So maybe just a quick overview of Telecom Malaysia. So we are the national connectivity and digital infrastructure provider and also Malaysia's leading integrated telco. So our mission is to humanize technology and make it accessible to all Malaysians in a sustainable manner. And so our portfolio ranges from wireless to wired to wireless. We have broadband, enterprise solutions, data center interconnect. We also provide wholesale transport infrastructure for the local ISPs. We have DCI, interconnect, and also digital and cloud infrastructure. So this puts us at an advantageous position actually to propagate IPv6 further. So over the years, TM, I believe, has played a significant role in propagating the adoption of IPv6 as well as the growth in Malaysia. So we were one of the first ISPs to proactively deploy IPv6 beginning in small scale adoptions before 2010. And 2012, when we started our dual stack broadband, we enable IPv6 connectivity to the end users. And since then, we also responsible to provide the transport infrastructure for wholesale customers in Malaysia, enabling other local ISPs to quickly jump on and deploy IPv6 quickly. And we've also been actively collaborating in government-led initiatives. So in 2015, for IPv6, there was a commission directive mandating dual stack service offering for Malaysia. So because of that, I think it boosted the about statistics of IPv6. Like if you follow any of the online statistics, like from Google, Akamai or APNIC, it shows for Malaysia the growth, I would say, has been slow but steady since 2012 onwards. And for TM, we are actively participating in standardization activities pertaining to IPv6. Myself, especially in global as well as domestic. So in terms of IPv6 compliance, so TM, we conform to the annual compliance audit by our regulatory. So it's done on an annual basis, and we have always supported and achieved IPv6 compliance for our network and services. So we align with global best practices and standards. Okay, so in terms of our solution offering, so we provide IPv6 ready solutions to our enterprise, such as cloud and VPN and data centers. And we see an increasing trend now for such enterprise and universities asking for IPv6 blocks. So it's good to know that they have started going on to dual stack. And recently also, some of our customers, university, which we help, not just in terms of providing connectivity to them, but as well as awareness and technical assistance. So we continuously establish IPv6 peering with global partners to improve our IPv6 reachability and performance. So to date, we have about 200 peering links, and it's growing. And finally, of course, we continuously participate in telecommunication events like today to continue to advocate and share of our experience in hope that we can perhaps inspire or influence other service providers to jump in on the IPv6 bandwagon. Okay, so next. So where are we now with IPv6? So if you look at the APNIC's measurement lab, it shows that Malaysia is second highest in Asia for IPv6 capable users at 69.5%, and among the top adopters globally. So this is I think partly due to the dual stack network and service that we are mandated to offer by default. So I think that's one of the main reasons why our statistics is very good. As mentioned by Prof just now, the country's IPv6 roadmap is currently being undergoing strategic revision to establish a clear and structured transition plan towards an IPv6 only state of deployment. So recently, TM, including TM, together with other local service providers, we've had to discuss what it takes for us to go to an IPv6 only state of deployment and what are our challenges from there. So it was a collaborative discussion, a very positive one, to see how we can support the government's aspiration towards an IPv6 only state soon. So this updated roadmap that is being cooked right now will define a distinct timeline towards maybe 2028 or 2029, and what are the key milestones that the stakeholders have to adhere to. So this in turn translates to growing number of requests that we see coming from government agencies, enterprise, as well as universities. So to date in TM, we see about 40% of our traffic is IPv6. Okay, so the huge success, as I mentioned just now, is due to the active collaboration that we have between the industry and the regulatory. So coming from regulatory, there was clear direction for dual stack, right? So everyone was mandated to provide dual stacks by default. So I think that was a good start. And of course, to make sure that everybody adhere to the regulation, there are the annual compliance audit. But on top of that, to ensure that our the local ISPs deployment are consistent with global standards, we also work together to develop technical code or guidelines to help not just service providers, but local organizations that are looking to deploy. Okay, so how did TM made it happen until today? So I think we acknowledge that they need to be proactive and lead the transition towards IPv6 rather than struggle with a last-minute shift. So I think that was a good call, and we make sure that we comply and align to the national policy to ensure a strong and seamless transition to for our end users. So for TM, we've gone through a few cycles of tech refresh. So there was significant investment made to ensure that we follow through in each cycle. We still sustain the dual implementation so that our customers will, can enjoy the seamless dual stack deployment. And with dual stack, of course, it allows customer and businesses to transition at their own pace while ensuring service continuity. Okay, so now that we know that IPv6, we need it more than ever, right? With the limited availability of IPv4 addresses. And, we've done dual stack for some years now. So we know that despite the depleting resources, there are still customers requesting for additional IPv4 block. So this morning I was listening to the data center discussion. Even there are customers data center asking for IPv4. You'd think that they will go for IPv6, but they still do. And I think it's largely because of their tenant or content providers who are still on IPv4. So we notice that this trend means some of these content providers are still prolonging the use of IPv4 through network address transition. So with the news of the recent revision or the undergoing revision of the roadmap, it provides good news to some of us. So finally, there is some urgency for us to go for an IPv6 only, for even to consider going for IPv6 only. So this new urgency will of course translate to growing requests for IPv6 connectivity, which we gladly want to embrace. And of course, in some ways, 5G accelerates IPv6 adoption. So from the massive device connectivity as well as in terms of low latency and high performance requirement from 5G, with IPv6, those things can be easily fulfilled. So I think for new networks, you should definitely deploy IPv6 from the start. Not even think of investing or maintaining the legacy of IPv4. Right. But when we talk about going to IPv6, it does come with a set of challenges. So we cannot deny, even know how positive or how much we want to embrace the end state. So we know that there are still many networks, content providers, systems that are still legacy and rely on IPv4 connectivity. And when this, we must make sure that the end user or the system they are using can still be compatible once we go to the IPv6 only state. So we see potentially issues, especially in banking, some of the famous online shopping apps. So there are still many systems and applications that rely on third-party services. So there might, there might be disruption if we were to go drastically to IPv6 only. And when we talk about the different transition mechanisms like Net64, 464XLET, yes, it provides IPv6 networks to connect to IPv4 only, but there's still issue of compatibility and applications that may fail. So those are the things that we need to tackle through thorough testing. But it's interesting to note Professor Fujisaki's slide just now, so I took a lot of notes. So I might just contact you later to talk about some of the working groups. So there's definitely a lot of potential there. So locally, domestically, when we discuss, we urge for a broader ecosystem adoption in order to accelerate to reach the IPv6 only state. So we're talking not just about service providers, but content providers, financial. So all these have to play a role to accelerate the migration to IPv6 only. And of course, finally, training, because IT professionals and network engineers need to be trained to build their skills in operating an IPv6 only deployment. So we're talking about operations, troubleshooting, and what are the security best practices. And of course, continuously provide public advocacy, just like we are doing now, continuous engagement with all the stakeholders coming soon. So these are some of the things we see are going to happen here in Malaysia for the next few years until we reach the final date. So whatever small successes that we have seen with IPv4, it is not the final destination yet. So our focus is to shift from our dual stack existence to going towards an IPv6 only. So there's a lot of things to be addressed, a lot of challenges, but it is a necessary progression, especially if we want to be relevant and sustainable. So thank you.
Thank you very much.
Sorry, any questions?
Any question? Please stand before the mic. Hearing none. Thank you. Down. There's a gift. Okay, thank you. So the next speaker, I'd like to invite Mohammad Andri Setiawan. He's going to introduce the Net AI Compiler, making a stateless IPv6 transition by using a AI-powered automation in the network management operation. Thank you. Welcome.
Thank you very much. My name is Andrew. So yesterday I attended a sessions by Jeff Houston, and I was a bit sad because the trajectory that was mentioned by Jeff Houston about the IPv6 looks bleak in the futures. So when I ask questions, what next? Nobody knows. Luckily, just now we had like a few presentations that actually showing the trajectory of the IPv6. It's actually quite good. My work is mostly done with the universities and government agencies rather than the telco, the ISP, even though we have a lot of discussions with the telco. But we see that this is actually the huge problem, especially in Indonesia, because when you deal with the enterprises, you will deal with tens, if not hundreds of switches or equipments that need to be reconfigured using the IPv6. You know, they have the knowledge about the IPv6, they have the workshops, but then when you try to deploy the IPv6, that will be a big problem. So as you can see over here, the first one is definitely a statistic that's been shown by previous presentation as well, that the Google actually measures that we are now reaching nearly 50% of the traffic actually coming from the IPv6. And in fact, in my own university, we have like 60% of the traffic right now is actually coming from the IPv6. So Jeff Houston actually mentioned about this one yesterday when he mentions about the CDN. So I asked questions a lot to my colleague from the ISP, define for me the internet. It used to be the internet is where your traffic is going international, but now the internet is actually local. Even in our case, where we have the Cloudflare, we have the Meta, it's only like 1 milliseconds. So it's your neighboring. And majority of the CDN, if I'm not saying 100% of the CDNs are actually running the IPv6. So it's actually good things to have the CDNs that makes, you know, it's the local, and every one of them is actually using the IPv6. So I did a lot of workshops. I did a lot of, like, since 6 years ago when I was with the APNIC as well. And I can say that majority of them, they do understand about the IPv6. But then we see the gap. We see the gap between knowing some things and want to implement some things. They're quite afraid. They have like a mental block. So apparently reconfiguring the equipment, it's not an easy job. In our case, when our university deployed the IPv6 in 2019, it took us like almost a year. We went back and forth with the ISP when we complained, how come our IPv6 doesn't go through to the upstream? I mean, like because they don't have a good policy. So the ISP always, we don't have any customer requesting us for the IPv6. Yeah, we do. We are the customers that are requesting for the IPv6. So they didn't have any experience at all back in the day. So based on our experience, we see that actually most of the problem actually coming from the mental block, that the engineers are afraid because they don't want to break the operations of the enterprises by implementing the IPv6. So these are a few things that I found during my project with this IPv6. Some of them, they say that IPv6 is too complex to understand. Others, they say that it's so hard, it's perceived to be harder, and it is true, like because of the number of equipment that you need to renumbers, and then lack of engineers who understand the IPv6. And then we see something that actually happens in the past like 2-3 years, where the AI actually coming, and we see the opportunity. So at first, like 2 years ago, we had an opportunity to test ourselves whether AI can actually read the data coming from our equipments. So in fact, this day in my university, we can actually talk to the chatbot and ask a question, something like this. Is there any problem with the access point on that building? Is there any problem with the Wi-Fi on that building? And then the chatbot will reply to us, yes, there is a problems. There is an interference problems just by looking into the data. And we see that, we can actually do some things with our network engineers, basically with the Indonesian network engineers. The opportunity, a really big opportunity, can we use the AI actually to say, for example, like this one, coming from the McKinsey. As you can see over there, the system infrastructures will be affected a lot by the AI. And one of the vendor that we use, actually, they provide a glimpse to us, trials to use the AI features. And we saw that actually they can. For example, if we are in this kind of occasions, the conference where you have hundreds of participants coming to a single room, and then you have trouble with the Wi-Fi connectivity. And then it can adjust the power, the frequency, they change the frequency and something else with the AI. So why don't we do the same things with the IPv6? So this is the testbed of the campus network that we work with. The name of the university is Universitas Ahmad Dahlan. It's in Yogyakarta, Indonesia, located in the central Java. So at first we test with the total building and distribution suites. They have 7, and then total VLAN per distribution suites is 4. That means they need to renumber 7 by 4, that is equivalent to 28. That was the first week when we did that one. And later on, we work with more switches. Now, this is quite small number of the VLAN. In our case, my own university, we have like 30 VLANs that we need to run. So if you can see 30 VLAN, that means you have at least 30 IPv6 per buildings. If we have hundreds of buildings, you can imagine the reconfiguration that we need to do. And our initial approach was we simply collected the IPv4 configurations from the equipments, and then we passed that configurations to the LLM. We are using the OpenAI. At first, we used the ChatGPT 3.5, and then later we used the ChatGPT 4.0 to convert the configurations from the IPv4 only to the IPv6. But when we tried that approach, somehow it gave us a lot of error. So because at first there are too many brands, switches and routers to cover. And then, yeah, that error, basically, okay, you can't really convert this one because you use the old configurations data set, for the LLM. That's why they do the things wrongly. And then we make some changes. We are focusing more on automation part because directly converting from the IPv4 to IPv6 gave you an error. But when we convert that one into YAML, into the Ansible for the automations, apparently it did really well. So what we did was we just simply pulled the CLI configurations, the typically IP4 only, and then we use that configurations, put that one into the Net AI Copilot servers, and we make this one open source. So we already published that one on GitHub. We will release this one once we have this project done into the public. And then we're going to update the current configurations using the IPv6 dual stack strategy. Like it or not, dual stack is the best options. To use another options like the XLAT and so on and so forth is a bit difficult for most people. And then once we have that once, we change to the Ansibles, and then hopefully, finger crossed, the configurations running well. So this is the design architectures, and this is the result. As you can see over here, this is not the only university that has used our software. We have another university, but I didn't put the chart here. As you can see, other organizations, usually when they deploy the IPv6, they will have like slope, like, you know, like 10%, 15%, 25, 50, 100. But this guy over here, from 0 to 100, in, I believe, it was like in a 1 week. The whole week, it changed from 0 to hero. So yeah, this is a good thing. I mean, like, we are quite happy with the results, and then we replicate these things into another university, and they do the same things, use the software, less burden, less stressful. Oh, this is nice. I can deploy IPv6 in no times using the Net AI Copilot. So this is the first approach that we have last times. We have the IPv4 only, and then I give them the IPv6, and then it will convert directly into the IPv4 and IPv6. But then problems happens, so we change it into CLI to Ansibles, and then we just simply put the device is Cisco, the device is MikroTik, the device is Juniper, blah, 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 and so on and so forth. And then we have that one on the right side, the YAMLs, you know, where we can reproduce everything at once. So we thank for the APNIC Foundations through the ECF Asia projects for their generous support of this work. Again, I have to say thank you very much from the APNIC Foundations, because all the works can be done through their supports. And one message from the ECF Foundations, they start to open the applications on the 18th of February. If you like to, they still have a chance until, I believe, end of March or April, I forgot, but that's basically the date. Thank you very much.
Okay, thank you. Before you step down, any question, please stand before the mic. Okay, please. Your name and affiliation.
Hello, hi, my name is Hadzik Raza. I'm from SIG Limited, Job Street. So basically, I have a question. I mean, good jobs that you managed to integrate with Ansible to create this sort of automation from IPv4 to IPv6. But do you have any future plan on other kind of integration from maybe something like changes into the variety of vendors out there?
Yeah, we basically going to have another one that we are working right now. It's actually, I'm calling that one as a self-healing equipment. So I spoke to a few people here in the APNIC meeting. So self-healing equipment is basically something that I used to ask my engineers whenever we have like a meeting like this, and then they will analyze, oh, there is interference in the systems. We need to adjust the frequency. We need to adjust the power and something like that. So from that log, we use the AI again, and we put some tutorials as an augmented document for the AI to work with. And then it basically will connect with the API to, to adjust the equipment accordingly. So this self-healing equipment means that we hope that whatever the event or whatever happens in any circumstances, the system will detect it automatically, and then will really adjust the configurations of the equipments in terms of this network operations accordingly with the help of the AI. Right now, we still call that one as a copilot. We have a testbed application for that one. We just need to make sure that human click that things. But up until today, we haven't had any confidence level to such that it will do the self-healing equipment. But we are quite happy with the result. At least like 60 to 70% of their suggestion is actually quite good. But we need to improve that one with more data to work with. That's our closest plan for the near futures.
Okay, thank you. Any other question? Okay, thank you. I believe the AI is replacing a lot of engineering jobs. Okay, before you sit down, there's a small gift. Okay, the last speaker, I'd like to invite Professor Ren Gang from Tsinghua University. He is going to introduce the analysis IPv6 adoption and in different perspective and a case study with a BitTorrent. That's have Professor Ren Gang go to the stage. Thank you.
Good afternoon, ladies and gentlemen. I'm Gang Ren from Tsinghua University. My presentation topic is analysis of IPv6 adoption in different perspectives and a case study with BitTorrent. Here are the main contents. Firstly, I will introduce the motivation of our study. Secondly, analyze of IPv6 adoption in two perspectives, IPv6 capability and IPv6 usage. Thirdly, introduce a case study of IPv6 adoption of BitTorrent. This chart shows that different organizations use different methods to reach their conclusions with some difference regarding global IPv6 deployment status. Our main motivation is to clarify this difference in existing IPv6 adoptions. More observation perspectives are beneficial for a better understanding of the current status of IPv6 deployment. And why a case study with BitTorrent? First is to give a decentralized insights contrast to most of centralized solution. Second is to complementary to most HTTP protocol solutions. And the third is to show the IPv6 advantages of its large address space. Next, I will analyze IPv6 adoption in two mainly perspectives. And this table shows the different metrics for IPv6 adoption. It can be categorized into two main categories. First one is IPv6 capability, and it can be further subdivided into client, server, network. And the second one is IPv6 usage, and it can be further divided into request, traffic, and connection. APNIC gives an example of IPv6 capability of a client. It uses online advertisement to send JavaScript scripts to the end user browsers. Google gives another IPv6 capability of a client example. It tests IPv6 users to access Google service. China IPv6 adoption rate measurement gives another IPv6 capability of a client. It cites a metric of IPv6 active users. It's the number of internet users in China who have utilized IPv6 to visit websites or mobile apps in 30 days. NIST and Internet Society and Eric Menker focus on IPv6 capability of server. It used the method to test IPv6 domain name resolution. Cisco gives another way of focus on IPv6 web content support. China IPv6 adoption rate measurement also focus on IPv6 capability of server. it has the way to test top 100 IPv6 capable apps and websites. From the view of IPv6 capability of a network, Cisco focus to do it through IPv6 prefix and transit AS. China IPv6 adoption rate measurement also focus on networks, and it divided the problem into 3 categories: the backbone network, the metropolitan network, and the mobile network. And another view is IPv6 usage. APNIC do it on its dual stack servers to calculate the IPv6 requests the portion. Facebook do similar one and to get the IPv6 traffic in its network. Cloudflare is similar to Facebook. And China IPv6 adoption measurement also focus on IPv6 network traffic. It divided the problem into metropolitan network and mobile network. It is important to note that different from the former, most methods are focused on centralized solution. In 2023, Cloudflare gives a solution of decentralization. It's based on the DNS resolver, DNS server in its network. It focuses on end-to-end IPv6 connections and make a calculation. For the end-to-end IPv6 connection, and the result is strong. It's only 13%. Furthermore, Eric Manker from 1909 to 2014 used BitTorrent to test the IPv6 peers with a decentralized method. We can make the conclusion of the difference of IPv6 adoption rate measurement. The first one is divergent measurement dimensions. And the second one is inconsistent metric definitions. And the third one is varied data collection method. Next, I will give an introduction of IPv6 adoption of BitTorrent as a use case. We all know BitTorrent is a peer-to-peer network where every server or nodes is connected to one another and all have the same capabilities. There are many mechanisms to find peers: checker, DHT, PEX, and etc. IPv6 is more favorable for the BitTorrent than IPv4 because it's a large address space. Here are our methodology. Firstly, we grab more than 1,000 hot BitTorrent seeds of a different resource. And secondly, we use a modified open source BitTorrent client transmission on a dual stack computer to download the resource and find peers by checker. Thirdly, we collect IPv4 address and IPv6 address of the remote connected peers. We set a metric of the ratio of number of IPv6 address among IPv6 address and IPv4 address number. And because BitTorrent is infrequently used on mobile device, the address collected may not include such addresses. Here are the results. The program is running in December 2024. From the view of all peers, we get 650,000 IPv4 addresses and 542,000 IPv6 addresses. We then keep only one address in one slide 6.4 subnet to filter temporal addresses. And from the view of responsive peers, we get 381,000 IPv4 addresses and 277,000 IPv6 addresses. From the view of all peers, the IPv6 adoption rate of BitTorrent is approximately 40%. And from the view of responsive peers, the rate is 37%. And also we have a historical view from 2014 to 2024. Belgium, for example, originally it was ranked #1, but its rate growing very slowly. It's only from 16% to 18%, while Malaysia grows rapidly from 5% to 68%. This chart shows the IPv6 adoption rate of BitTorrent of top 10 economies in the world. Also, we provide APNIC, Google, Facebook, APNIC, Cloudflare to make a comparison. From the group view, we see the different tests are nearly the same. But from the view of a different country and regions, it has difference. For example, United States, Germany, and United Kingdom, the rate of BitTorrent IPv6 adoption is lower than that of any other method. And for China and Brazil, the rate is higher than any other method. This chart shows the top 20 rate of IPv6 adoption of BitTorrent, the countries. And we also provided the result of APNIC. We can see there are some difference between them. And most of the 20 countries are from Asia, Africa, and Latin America. This chart shows the geographical difference of BitTorrent IPv6 adoption rate. The horizontal axis is the number of IPv4 addresses per 1,000 people. And the vertical axis is the rate of IPv6 adoption of BitTorrent. We can see for the countries get a higher rate of IPv6 adoption rate of BitTorrent, and the lower the IPv4 address per 1,000 person can get. Here are the conclusions of our case study of IPv6 adoption of BitTorrent. We got 37% of IPv6 address in global BitTorrent network. And there are differences with APNIC and other measurements in the country and the regional view. From 2014 to 2024, the growth rate in European and American countries was much smaller than in Asia and Latin America countries. And the top 20 are largely comprised of countries with limited IPv4 addresses resource. Thank you for listening.
Okay, hearing now. A sent gift to you. I think today's presentation will be very helpful for your consideration when you try to adopt IPv6, especially consider in different methodology or different tool, and especially AI tool. I think that's very helpful. Okay, before we leave, can I ask everyone we give a big hand to all speakers today? Okay, thank you very much. Thank you for your participation. This section is officially concluded. Thank you.